All right, let's dive into a skill that really, truly separates professional C# developers from everyone else: dependency mocking. If you're serious about writing code that's clean, reliable, and actually maintainable, this is something you just have to master. So let's get right into it.
So have you ever been there? You've written a whole suite of unit tests, but they take forever to run. Or maybe even worse, they fail randomly because the network blipped out or some test database wasn't available. It's incredibly frustrating, right? Well, today we're going to fix that.
The solution is something called dependency mocking. Honestly, the best way to think about it is like this. When your code needs to talk to a real database, you don't bring that whole massive real database into your tiny little unit test. No way. Instead, you hire a stut double, a fake version that you can control completely. It does exactly what you tell it to every single time. No surprises. That is the core idea of mocking. So here's our game plan. We're going to break this down into 5 parts. We'll start with the big idea, then get into the essential techniques, and even some advanced scenarios. We'll walk through a real-world example, and then we'll wrap up by talking about the mindset that really takes your testing skills to the next level.
Okay, first up, let's really nail down this core idea, because understanding why we do this is way more important than just learning the code. The why is everything.
I mean, just look at the difference here. It's night and day. On the left, when you test with real dependencies, things are slow, they're unreliable, it's a mess. But on the right, with mocks, our tests are suddenly lightning fast. They're totally isolated, we're not testing the network anymore, we're testing one thing and one thing only: our code's logic.
And that brings us to the golden rule of mocking. Seriously, if you remember just one thing from today, make it this: always, always mock interfaces, not concrete classes. So why is that? Well, because an interface is like a contract. It just defines what something can do, but it doesn't care how it gets it done. This gives you this incredible flexibility to swap in a real database for production, but a super fast fake one for your tests.
Okay, we've got the why down. Now for the fun part, the how. Let's get practical and look at the essential techniques you're going to be using every single day.
In modern C#, pretty much everything is asynchronous, right? So how do you mock an async method? It is beautifully simple. Instead of the usual returns function, you just tack on async and use returns async function. That's it. This tells your mock to act like a real async call, but without any of the actual waiting.
So you've set up your stunt double, you've told it what to do, the test runs, and it passes. Great. But wait, how do you know your code actually called the stunt double? How can you be 100% sure that interaction you were testing really happened?
This is exactly where the verify method comes in. It's your proof. It's your receipt. You can use it to confirm 3 absolutely critical things. 1, that your mocked method was called at all. 2, that it was called a specific number of times, say exactly once. And 3, that it was called with the correct data. This is what closes the loop on your test. Okay, fundamentals are down. Let's level up, because great tests don't just cover the happy path. They handle all the weird, tricky edge cases. Let's see how the pros do it.
Sometimes you really don't care about the exact value being passed to a method. Like, does it matter if the ID was this specific GUID or just that any GUID was passed in? That's where it.isAnyT comes in. It makes your tests way more flexible and resilient, so they don't break just because some tiny irrelevant detail changed.
Now this is a huge one. You have to test for failure. What happens when that API you're calling is down? You can actually simulate that by telling your mock to throw an exception using throws or throws async. This is absolutely vital for testing your error handling logic and building truly robust applications. Okay, theory is great, but let's see this stuff in action. We're going to walk through a classic real-world scenario, testing a simple email service.
It really just boils down to a simple 3-step dance. First, you set up your mock, in this case for the iEmail gateway. Second, you call the method you're actually testing, send greeting email. And third, the crucial part, you use verify to prove that the send email method on your mock was called exactly one time. That's it. A perfect, clean, isolated unit test.
So, we've covered the mechanics, the code, but now let's talk about the philosophy. This is the stuff that separates a good developer from a truly great one when it comes to testing. It's not just about what you can do, it's about what you should do.
Here are 4 key best practices. 1. Only mock things that are external to your system, like a database or an API. Never mock the actual class you're trying to test. 2. We've said it before, we'll say it again.
Always prefer interfaces. 3. Test what your code does, its final output, not how it does it internally. And 4, and this is a big one, don't overuse verify. If you can just check the final result, that's often better.
And to really hammer those points home, here are the common mistakes we all need to avoid. Don't mock absolutely everything, that just makes your tests brittle. Don't even try to test private methods, that's a sign your design is off. Don't forget to test what happens when things go wrong. And please, don't just slap a verify on every single call just because you can.
So when should you use verify? Well, here's the senior level insight. You use it when the interaction is the result. Think about it. When you send an email or save something to a database, you don't really get a useful value back. The important outcome was the sending or the saving. That's the perfect time to verify.
You know, if we had to boil this entire explainer down to just one single sentence, it would be this. Mocking dependencies using interfaces is what allows you to write isolated, fast, and reliable unit tests. That right there is the foundation of a professional testing strategy.
So, I'll leave you with this question to think about. Go look at your own code, your own projects. What's the one part of your code base that you know needs better tests right now? And how can you use what we just talked about to finally make that happen?